This one. Maybe I should get rid of the Signal app. I don't need that at all. I know the Teams app. Nobody needs that either. Cool, cool. We're on. We're live. Wait, hold on. Did I change? Yeah, I actually changed. This is so dumb. I love that. I love that thumbnail. It looks so stupid. That's crazy, dude. Can I see my own channel? Does it show up there? Yep, it sure does. It sure does. Okay, let me just get rid of this one. I'm still slightly annoyed of stream elements showing up on the stream, but sure, what can you do? Okay. We are mostly ready, I believe. Yeah, that's fair enough. Should I turn on the Spotify? Should I turn on the Spotify? Because it's like literally, it's just rain sound. There's nothing but rain here. So I'm not sure if that's off, if that's valuable to anyone to hear that. Well, we have live somewhere. Nobody here, which is perfectly fine by me. Yeah, what are the hashtags? Did I change those actually? I did. I did also change the tag, so it should be relatively clear what we're doing here. Okay. Let me just give that a few minutes to and just move Discord over here because we don't need that. Nobody needs that. Nobody needs that when you're doing things that are of any importance. Oh, Photoshop there. Right, when I was doing this stupid thumbnail. Otherwise, it seems like we're okay. Give Discord one more quick look. Shouldn't be looking at that too much. Okay. Looks good so far. Now I just have to manage to actually focus on the thing that I'm studying. Okay. So, um, the thing is this. I got the thingy over there. I have a drawing tablet here, which currently doesn't serve any purpose. So the thing is this. I already learned, or already studied the entire chapter about permissions, theoretically. So I just have to kind of realign in my head what I've learned. So we have three different types of permission. We have permission types, which are like the standard permissions. We have the special permissions, and we have the access control lists. And all of these are a more granular way of managing permissions. Now, what was the overarching term for owner, group, and others? Because there was like a category. It's like permission what? Permission resources? I don't know. Actually, this is like permission systems. This is more like permission systems, and these are permission types. So we have owner, we have group, and we have others. But that's like the standard permissions. In terms of special permissions, we had set UID, set GID, and sticky bit. And all of these are wait, are these access levels? I'm not entirely sure. access. I think those were access levels. We have like read, write, execute, of which these relate to 4, these relate to 2, and these relate to 1. In terms of commands, we have change owner. I think change group is a thing that you can do. Even though you can do that with change owner as well. You have umask, you have was it set, is set UID a thing? No, you do that with change mod. Or SEMA. I keep forgetting which one of those it is. CMod, umask, get FACL and set FACL, and those are the things that you kind of need to manage groups and permissions. There was also a special permissions are like there was also the what's it called, the permission toolkit that you can use, and those are the PK commands like PK exec, PK list, PK action, PK TTY agent. I'm not sure if there's any others, but those are the main ones. Why am I not watching chat, by the way? Using Windows while learning about Linux is some kind of specific hustle. Like, listen, man. It is really hard to use DaVinci Resolve on Linux. I haven't managed to do it yet. It is a bit of a hustle, but it is better than the pain I have to go through of making the editing software work on actual Linux. And I don't know why that is. I think it's because of the GPU. It doesn't work correctly. I haven't figured it out. And good friggin' luck. Good friggin' luck trying to get near... Wait, which was it? Near Replicant running on Linux too. Tuners on Arch between. Man is on Arch Linux, like a true Chad. Man, I wish I was an Arch user enough to be a cute femboy, but we're not there yet. Okay, where was I? Well, we do have Windows. However, we also do have virtual machines here, which we can use. So that is a thing. I'm just not sure where I am in terms of. Okay, I'm in root. Awesome. Wait, is that a directory that I have already? It is. Awesome. Cool. Why is there a cloud init in here? What's in there? What the hell did I do? Okay. Well, I guess I was doing virtual machines at some point, and that's why we have that there. Okay, fair enough. Okay, touch test. Like, I still don't really understand the sticky bit situation. What does the sticky bit do again? I know I can do that with, like... What the hell was it? Read... Right, sure. 166.1644 on test. And it should have sticky bit right now. Yeah, okay. So it has the sticky bit here. What was the sticky bit again? I think sticky bit is like you can execute the file as a different user. Is that what it was about? Or you can or it's always executed as the owner. Is that what it did? Hold on. File management, key directories, implementing summary. No, wait. That is a different topic. Permission concepts, view permissions, default permissions. I know about these. Absolute and symbolic modes are relatively easy. Ownership attributes. Where's the goddamn sticky bit? So what is it? Just that only the owner of a file or directory can... Okay, that's different then. Without the sticky bit, any user with write and execute permissions of an object can delete the object. Well, that's different. Okay. Sticky bit ensures that these users do not have delete privileges, but still have the rest of the privileges that come with writing and executing files and directories. Okay, so if I'm a different user, then I can't delete this, even if I have execute permissions. So if I go there and say that dmod is 777, everyone can do anything with this goddamn test file. Do I already have another user here? Oh, I'm already root. Never mind. Never mind. I have to do no such thing. User add -d home. We're just adding Pecora again because for some reason I'm always using Pecora as a user, as a test user. What is happening? We're studying Linux. For some reason, it's way easier for me to study when I'm on stream. It makes me focus a lot more. And I also sometimes, like, random people drop in that you can explain things to, and then you're also teaching it, which makes the things sink in even better. Literal lock-in. You always lock in. On a Sunday morning, you always gotta lock in. Yo, what the fuck was I doing? Dakota. What do you mean? The user does. I literally just. Oh god, I'm stupid. I created Pickle. Pickle. Alright, fair enough then. I'm sorry, sir. We're only speaking English in this stream. This is a US American owned stream. Okay, so that was so Pickle. What do you mean? Oh, we're already there. Never mind. In which case, I shouldn't be able to do that, right? Cannot remove test. Permission denied. Okay, so... Can I change it, though? Wait, that's stupid. Hello? Okay, sure, we don't have bash, I guess. I can pipe things into it. I shouldn't be able to do that. Right. Oh, execute. Right, I shouldn't be able to execute it. Oh, never mind. Okay. Okay, no, I got it. Any user... Okay, so it's just about delete. The gibit is literally just delete. What's it do? Prevents other users... prevents users other than owner from deleting files. Cool. Other thing. Wait, honestly, not a mirror. Chat, by the way. That's on stream. Okay, awesome. That still works. Gentoo. Is Gentoo really important to understand the basics? To understand the fundamentals of the system? I wouldn't think so. Okay, sure. Other thing was if I were to make a sample directory. We have... Which one was set GID? Was that 4 or 2? I absolutely have no idea anymore. That doesn't do anything, right? How do you set the other thing then? Wait, it has a thing here, but I don't think that's what I want. That's right. Stupid, actually. Okay, that is what? Set group ID. Meaning that if I were to... Well, I mean, it's also probably not smart to create that as root, considering that nobody else can change anything about it. Never mind. I'll go back to Pecco, make their sample. Permission denied. Cool, obviously. And City 2. Why not? What do you mean? Also, why doesn't Pecora have a shell that is of any value? User mod minus s dash pickle. Does that even exist? No, it doesn't. Awesome. Cool. What did I want to do here? So it's sample. Cool. Awesome. I understand. Then we make a sample directory. Why am I not allowed to do that? Am I not in Pecco home directory? I am. Why is that not a thing that I can do? Okay, anyway. What is the pseudo group in the system? Is it pseudo or wheel? It's groups, right? It is pseudo, okay. In that case, we are doing... Going on. Nothing. Awesome. Minus AGL pseudo onto Pecco. Such that Pecco can do whatever the hell she wants. Did it even set her home directory? I don't know. Sure. There we are. But is it it's still root. Right, if I run it via sudo, the permissions are gonna be root all the time because it's executing the command via sudo. Well, that doesn't do anything then. Honestly. I was trying to do a thing. I was trying to learn a thing here, but now I'm dealing with this nonsense. Oh yeah, that is Pecora's directory. I don't understand. Okay, that belongs to root. Well, never mind then. No, wait, I need Pecco. Now it belongs to Pecco. Cool. Thanks. Very glad. Very glad we cleared that up. Can I do my thing now? Okay, so dmod 2777 Pecco. Should give it the... Oh, okay, thanks. Should give it the GID bit. So if I go to root and I were to head over to Pecco's home directory and touch a file in sample. What do you mean? Oh, the directory is Pecco now. Fair enough. Then, yeah, okay, got it. So set GID is like if you set the GID on a directory, then all files created in that directory will belong to the original group of the directory. I'm not sure if that applies to other directories too. Pecco. Example. It does. And also any directory nested inside the one that has the GID bit will also have its GID bit set. Fair enough. So the last one was set set UID, which I believe was what? Going back to Pecco. We're making a script as H. And that is gonna be 1. No, wait, it's 4, I think. GID is probably 4, because it's always 2. It's always 1, 2, 4. Because octal shenanigans. 777, I don't give a crap. Hello? Thank you. Bin bash. Echo. What was the environment variable for the current user again? Get current user. Oh, it's just $user. Gotcha. Okay. Then execute script. That'll give me Pecco. If I do it here, if my memory serves right, it should give me. It should still give me Pecco. No, it gives me root. Okay, then what the hell does that bit even do? Or did I set it? I did. Okay. Then I guess I'm wrong. Well, what did it do then? Set user ID. Is the permission that allows the user to have a similar permission as the owner of the file. Certain executable files and commands such as password require access to additional resources that the user may not have explicit permission to. Instead of granting those permissions individually, the password command is configured so that any user will execute it as root, giving them permissions to the additional. Okay, so well, I would be correct then, but I can't see that here. Maybe it's because I'm root and everything just gets executed as root when I root it. No. Okay. Wait, maybe I did it incorrectly. No, SUID is set UID is 4. So that's correct. Sticky is 1, set GID is 2, set UID is 4. Now the question is, how do I get script executing the user? Sudo user it's still a user, right? User contains as username when he calls sudo for new subshell. I would still like to understand that UID bash script. Why does it not work? Why not work? Why no work? Yeah, really, why no work? Essentially shebang, blah 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 blah, whatever. The kernel inserts the power of the script. Yeah, it's argv1. I know. How do I see that? How do I see the effect of set UID? We're doing wrong with running face first into a security measure. Detect that they're being run set UID root and immediately drop privileges on launch. There's a really easy workaround on launch. UID is okay. I mean, it still doesn't tell me anything, right? It still doesn't mean I'm gonna get it. If you set SUID on the actual executable or a copy, it will not actually escalate to root. Okay. How do I see the effects of SUID? That's not what I was looking for. I'm sorry. Numeric method, special permission, user S. SUID, the special permission for the user access level, has a single function, always executes as the user who owns the file regardless of the user passing the command. If the file owner doesn't have execution permissions, then use an uppercase S here. The practical light, let's, okay. Wait, does that mean that I would be seeing a different thing denoted differently, or no? It's still a lowercase s. Okay, fair enough. Good user bin password. User bin password is like that. Okay. S where X would usually. I guess. Oh yeah, hold on. Actually, I think what is happening is that what is actually being executed is bash. Like, it's not actually the file that's being executed here. So it doesn't take the... Yeah, okay. Yeah, okay. The bash is still executed as that particular user. And since then bash looks at the script and runs that, the one that received the executing user originally was bash. I see. But that only works for compiled binaries then. Okay. Always executes a file as the owner. Only works on compiled binaries. If used in a bash script, Linux will, the owner will be passed to the bash binary. Okay, interesting. Gotcha. What does it do though if... Does that do anything on files? Okay, it does the same as SUID, but for directories it has an additional function. Always executes a file as the group. As the owning group. If set on directory. Wait, hold on. I need to know something else. Example. Wait, where did I put it? ls minus al example. There's nothing in there. Cool. Touch example. So that has the group set on it. Permission denied. Okay, fair enough. Whatever. Okay. Then example is the one with the group ID set on it. Touch example test. Okay, so the file will still be, so there's a different logic here. If set on a directory, New files in the directory will inherit the directory owner. And new subdirectories will inherit the directory owner and have SGID bit set. Easy, theoretically. Does some very okay, so default permission, wait, system-wide permissions for new files are set via umask. And the default Linux permission set is 666. Umask is subtracted from the default set to acquire new file defaults. That's how I think it worked. Okay. We have owner, those are changed by change owner, change group. I think change group is a thing, right? Oh, we are on root. So if I click the example file, that's a file, right? No, it's a directory. Never mind. But I could go change group and change that to honey. Yeah, that works. Okay, gotcha. Cool. So those are the default and the special permissions. And then there's also symbolic and what is the other mode? Symbolic and absolute modes. Cmod. So you can go cmod. Just set none of these with read, write, execute, read, write, and read for sample, for instance. And you can do the same with, I think it's U equals, or no, it's O equals RWX, G equals RW, no, RX, and O equals X. Wait, that's not what I wanted. God damn it. Sample. Then you can do the symbolic mode. I think you can also like use it like this to set no permissions for others, for instance. Yeah, okay, that works. Those were the symbolic and absolute modes, which is relatively easy. When you get the absolute modes, they're actually not that difficult. That leaves the access control lists, which I'm not sure about anymore. You can get access control list settings with get facl and sample. Huh? Is that not the right one? Is that not the correct command? Is that not how it works? Wait, man. Do we not have that by... Does Debian not have that by default? Cool. Okay. Also, I don't need to see all of that right now. Can you close that, please? Yeah, okay. New mask is this. We don't need that. I'm worrying about about the ACL nonsense. Why do we have that in here if it's not default? Or am I misremembering it? So these are a way to give permissions to individual users, like file permissions to individual users and groups. So you can add multiple owners to something, for instance. ACL is enabled to assign permissions to individual users or groups, even if these do not correspond to the user's object. Yeah, that's fair. But what was the command then? Get FACL. Wait, that's what I typed. That doesn't seem to be default then. Okay. I guess not. Well, okay, I guess we're installing it. Crap. How the hell am I supposed to do that? I thought that was default. Get FACL. Edit the following source line to app configuration. Okay. That's release. Okay. And what about ACL? Can we install that? That actually works. Okay, sure. Interesting that that's not default. That's not It's not part of the default new Linux tools. No default new util. That is very sad. So set FACL. God, how did that work? There were options to that command, but God, if I remember those. That B is remove. Recursive, logic and physical version. Like, how do you add things? Follows and performance plan. Okay, blah, 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 blah. Can you get me a granting an additional user read access? Oh, I see. Revoking write access from all groups and all named users. Removing a named group entry from files ACL. Okay, -X is remove and -M is modify, I guess. Oh, I could copy an ACL from one file to another. Interesting. Okay, so I can go and set FACL -MU me and give me read and execute on sample, right? And then I should show up here as an additional user that has the rights to do that. Cool, gotcha. So what I've forgotten here, what's relatively important to know, is -MU username RWX, depending on what you need. And then -X is username I don't know, W, because everything else is usually fine. Cool. That works. In which case, I'm sort of happy with that. Alright, fine, I'll move on then. I no longer need to know that. Or rather, I know it well enough. Understand Linux system. Okay, like lesson 4. I'm gonna have to move faster on these. I wanted to get the certificate in like October or November, and there's still 10 lessons to do. I'm relatively certain that I could pass it anyway, but I'd rather not take my chances. File system. Okay. Okay, seriously, before I read any of that, before I literally read any of that, I want to have an overview of what's happening here. File system. So, we have lesson overview. Because I need to know, before I study a single thing, I need to know what is the overarching structure of information in this chapter. Okay, we have the organization of files. We have the file system hierarchy, okay. Subdirectories, okay. Key directories. Okay, so that's it. That's file system hierarchy with top level, no, like, is it top level directories or is it root directories? Root directories and key directories. File metadata. Oh, wait, you know what I forgot in the permissions chapter? The file attributes. Because you can set attributes on the things. I'll return to that later. Just keep it in mind. When examining file can be used for blah 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 blah. I don't care about that. Use the stat and file commands. Okay, so stat, file metadata, that, and then there's naming conventions. How does that fit into anything? That's weird. I'm not sure how to make sense of that. File naming conventions. All right, sure. Whatever you say. What's the next one? Absolute. Okay, that's easy. I don't think I need to. Path. I'll still write it down. Which means that's path. What is that? Path types? No. Path notations? Notations, I think. Absolute path. Relative path. File links. I don't know what that is. Oh yeah, right. Soft links and hard links. File links, which means soft link, hard link. Symbolic link is different. Oh, symbolic link is a soft link. Okay. We have symbolic link and hard links. File management. Yo, that you're doing that now? That is the lesson you choose to do after permissions? Oh my god, man. Yeah, fine, fair enough. File system management. Like file system navigation. Navigation. Yeah, sure. File management center starting the product. Yeah, what does that mean? Yeah, okay. Direct. Yeah. So it's just like, that's all file system navigation. And it's file system manipulation, more or less, because you're creating things. So all of these, those are the really simple things like cd, ls, touch, ln. What is the other one? Stat, make directory. Yeah, I don't think I need to waste too much time with that. Okay, yeah. This is the manipulation. It's like copy files, move files, and so on. Copy and move is obvious. I know those. Display project file content. It's like, okay. File. What is that? What would that be? What is cat? File information extraction, file reading. It's more like directory movement. Okay, I'll put it here under reading files. And it's like cat as part of that. I'm not sure if I need to study this at all. I might just give that a quick read to see if there's anything that I don't know or anything that I'm shaky on, but generally. In general, never assume that you know things when your brain tells you that you do. Your brain is intensely skilled at betraying itself. When you feel like you know something without having read it, that is a very good indicator that you're wrong. Okay, what's the next one? Remove directory. Okay, fair enough. Copy files, directories, move files and directories, and remove, or like, yeah, fine. Remove files and directories. Oh, remove directory is a command. Actually, I didn't see. That's one thing that I was shaky on. I didn't know that existed because I never use it. You only use rm-f. Because why the hell would you use anything else? But someone's going to ask you about it, and then you're like, oh, I don't know. I don't know what that is. Oh, gosh golly. Gosh dang it, Batman. Okay. Display files? What do you mean? Oh, yeah. I mean, less is a thing. Head is a thing. Tail is a thing. Grep. Yeah, okay. You can use grep directly on files. Extract information from that. Meaning I could do, I don't know, what's it called? I could go back to root. Am I root? I am root. So for instance, I could go grep -I, then use, and then uppercase that, and then still find it. Got it. It's fine. Wait, by the way, what sort of shell am I using? Root, root is using bash, as I would have expected. Very nice. Cool story, that. And we don't need the redirectors. Those were these ones, right? And pipes. Oh, I guess you can also do that. file. Okay, so redirection, like text streams, which means standard, standard in, standard out, standard error, and how to redirect these. Oh yeah, okay. Okay, I'm a little shaky on the redirectors. I mean, this is put into file, this is append to file, this is is that error? Yeah, that's redirect error. That's append error. What the hell is that again? Redirected in a file named. Redirect both the standard output and the standard error. Okay. Read the input from a file rather than from the keyboard. Okay. Yo, those are redirection operators. I might have to take a closer look at those, because those are, I'm a little shaky on them. With this, we have both of them, which means this and this should also work. With the other direction, and we have this actually, which I wasn't aware is a thing. Okay. What's the other one? Command modifiers. Oh my god. Background command. Why is this in file system management? Ground modifiers. Chain commands, piping. Okay, yeah, that's piping. T command, xargs, all of these. Yeah, all of these are things that I need to take a closer look at. Not necessarily right now, because I didn't want to study for too long. But eventually. Background command, chain command. Then we need T, xargs. Okay. This is already almost too much to absorb, even though I know a bunch of these already. Search command. Wait, what do you mean? The locate. What the hell is locate? What the heck? Find files. Okay. Finding files and directories. Find. So we have find and we have locate. Find, locate. Oh. We make searching easier in a very large file system. So which command displays where a command executable is stored? Which? This is actually a relatively large lesson. I mean, I know a lot of these things. But still. File manipulation commands, the echo command. Yeah. I mean, I have file manipulation right here. I think that's also something that can go here. Even though it's a different topic, but it like generally fits under that lesson. Printf. I love printf. Nobody uses it, but I think it's goated. TR command. Translate. Oh yeah, right. I forgot that that exists. Word count. Sort is a thing that I learned about at some point. Cut is something that I use frequently. Haste. Okay. And diff. Okay, sure. Dear God, chill. God. I might just skip over AWK. Nobody knows how it really works. And it's a science in itself. Know that it exists, but don't worry about it too much. That command is crazy. By location, okay. So that's the entire lesson. It looks like a lot, but it actually isn't, considering I know most of this already. My problem is that my brain doesn't want to cooperate with learning all of that right now. Alright, hold on. Thanks, Semi. God, didn't even see you there. Hmm. Okay, so let's see. What else did we have? So now that I have a good idea of the entire structure of the lesson, I can sort of dive into what I don't know yet. All of these things are sort of obvious, so I don't really have to waste too much time with that. Maybe there's some technical detail about the text streams that I'm not familiar with that would be useful, and the redirection operators. Those are kind of good. But I don't think my brain is ready to understand that, so I'll go back to the basics and see if there's anything in here. If there's any information in one of these things that I don't quite understand yet. So root directories and key, that's like the file system hierarchy, okay. So if I remember correctly, file system hierarchy, we have in the root directory var, we have etc, we have etc, we have home, we have opt, we have lib, bin, sbin, which are kind of legacy things that are not really used anymore. I think they're actually symlinks at this point, but I'll check that out later. We have run, we have sys. Where are the other ones? Am I forgetting anything? Home var bin sys. There is on some systems SVR exists, which is supposed to be the next var www, but it's not used everywhere. Opt home etc sbin bin sun. What is sun? Bin. No. What was I writing? A run. Run temp. Temporary files in it. That exists. Where programs just kind of deposit all of their temporary shit that nobody needs anymore in when they're done with it. Okay, so let's see if I missed anything. We have our trusty Debian here. Can actually... God damn it. There we are. Okay, so I was right. The bin directory that still exists is a symlink to USR bin, which is... Did I even write USR? I don't think I did. Stands for Unix System Resources, by the way. So we have that. Both of these are symlinks to stuff in there, which is some sort of legacy thing. We have home, we have etc. We have dev, which what the hell was oh yeah, device. the device files. Media is, I'm not sure if media is a general thing. That's usually where you put your flash drives, your things that are not built into the machine, all that kind of stuff. Storage media, hot swap storage media. You have mount, I think that's standard, but it's rarely used unless you are in Arch setup where it is absolutely used. Opt SRV, that does have SRV, it is USR, it is var. Run root proc, I think proc is one of them, which contains all of the process files, like information about running processes. And then everything else is like not. Oh, but boot is default. Boot also should be its own partition, but I'm not sure if the virtual machine treats it as such. Def run, okay, no, it doesn't. It doesn't care. It doesn't care. Frequently, boot will be its own partition, which is safer most of the time, because then, or actually, I thought you have to do that because boot needs to have its own. Hold on. Boot needs to have its own partition scheme. It needs to be FAT32, right? Or doesn't it? Maybe virtual machines are just built different. I don't know. Crazy. Crazy how that works. Okay, we have those. Like, these are user configuration files. So these are the ones that you can change. These are also configuration files. Application configuration files, normally not changed by users. This is initramfs, it is kernel, it is bootloaders. This is default mount point, which is also like getting a little deprecated. This is hot swap storage media. This is device files, e.g. block storage. These are system. This is like everything. System resources, binaries, super user binaries, symlink to USR SBIN. This is regular binaries, and they are also symlinked to USR bin. Run application temporary files. I think that's volatile and deleted upon reboot. Run. Run? I don't know anymore, honestly. Proc is running process information files. I think that might also be volatile. Var etc. What is var again? What is the definition of what's in var? I know there's like log files in there, and sometimes web servers, and I don't know. It's just like, what's the definition of that? Frequently changing system files like logs. It's web server files. I don't know what else is in there. Let me see. So we have etc contains files and subdirectories of configuration information for the system and its services. Yeah, but it's usually system configuration files intended to be changed by users. So these are the ones you can touch. Home is your own home directory. Those are user files. Home also tends to be on its own partition, but it doesn't have to be. And sometimes I find it more convenient if it isn't. Root is root. Oh yeah, I forgot root exists. Goddamn. var log, Linux typically write log. Okay, so these are, this is what you consider the key directories. Key directories. So that's home, that's root, obviously, that's etc., and that's var logs. Okay, I can live with, I can work with that. I can work with that. So all of this is adheres to the files root. Okay, and again, root level directories on Linux adhere to the file system hierarchy standard. And that was invented in, I don't know, 1980 or whatever. So let's read this. Well, there are a great many Linux distributions, thousands of them with varied utilities for varied uses, yes. So Ubuntu is not the same as Kali when it comes to software that is pre-installed on it. There are a few things the distros have in common. These common features allow compatibility between Linux offers and permit a certain amount of comfort and standardization with regard to where find and specific types of files. Yeah, these common features are usually defined by some sort of standard that exists, one of which is the file system hierarchy standard. For example, Linux distributions store most configurations in the etc directory. Most users have a private directory in home, and log files are found in var log. Such standardization, okay, these are also the key directories that they list. Such standardization allows software installers to expect resources in certain locations and sysadmins to anticipate where particular settings can be found. This standardization is achieved via the file system hierarchy standard. There we are. Is a collaborative document that specifies a set of guidelines for the names of files and directories and their locations on Linux systems. Most Linux, document, collaborative document, so people collaborate on it. Read the sentences slowly, really understand what they mean. Specifies a set of guidelines. That's what a standard is, it's a set of guidelines for the names of files and directories and their locations. So defines file common file names, common directory names, and their locations. I consider that important information. Most distributions are FHS compliant and therefore support compatibility with other systems. The FHS also creates a naming convention that helps administrators, users, and applications consistently. Naming conventions. Yeah, okay. Fair enough. We already wrote that down here. That helps administrators, users, and applications. Okay, this is important. This is important. Also allows applications to rely on the similar structure of file systems. That is really important. When you're writing something on Linux, you know to a certain degree that no matter what distribution you have, they all adhere to the same standards to a degree. And that's really good. Stores where other entities can easily find them. As defined in the FHS, the topmost directory in Linux file system is the root, indicated by a single // Below the root directory are various subdirectories that are standardized as part of the FHS. Yeah, we have bin. That's not really a thing anymore, so don't worry about it. We have, okay, what did I write down? What did I write down before? Bin, regular binaries, that is now symlinked. We don't care about that anymore. File to boot the Linux operating system, which includes the kernel. It includes the initramfs, which has all of the kernel modules, or like some of them. And it includes the, whatchamacallit, the bootloader, like grub. Dev stores hardware and software device. Okay. Imperative here is that it is hardware and software devices. Linux has software devices, such as dev null or whatever, where you can send things to and then they just disappear. It also has like dev random or whatever. Dev random. Alright, sure. We have all of these things. But it also has dev zero, which is another software thing. So it includes, did I write that down? Where even did I write dev down? I think I forgot about it initially. Device files, hardware and software devices. It's actually important. etc. So these are basically, as I understand it, ways to interface with the firmware of an actual hardware device. So you can send like syscalls to those files, and then they will go to the actual hardware and make it execute things. That's my high level understanding of stuff. Stores basic configuration files, for example, the blah 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 blah. Okay, yeah, those are meant to be configured by users. Home user information, user personal files, lib, program libraries required. Oh yeah, right. They also store they store application configuration files, but they also store shared libraries, which are important for applications that are trying to run on Linux, because they know that, for instance, they can find all of the C libraries somewhere in lib. Very important for anything that you write for Linux. Kernel, command line utilities, and yeah, shared libraries, media, mount points for removable media. That was the word I was looking for. Removable storage media. Mount for temporary mounting file systems. Default mount point for temporary file systems. Opt. What the hell does opt do? Optional files are for large software packages. These packages normally create a subdirectory bearing their name under opt, and then place their files in the subdirectory. For instance, opt Nessus contains files for the Nessus vulnerability scanning program. Interesting. Is there anything that I have on the virtual machine that would require opt to exist? No. I see. Default storage of configuration files for large software packages. Usually subdirectories, usually named after the applications. Okay, that's what opt does. So if you don't have a relatively large program running on your system, then opt doesn't do anything. Proc. What the hell is proc? Virtual file system represents continually updated kernel information to use in a typical file format. But isn't proc the process information? I thought that was what it was. This is just a technical explanation of what it is. It doesn't say what it contains. I mean, I guess. Root is the root user home directory. Personal user files and maybe what's it called? Flatpaks? Flatpaks. Root user home directory. Espin, that doesn't exist. Sys is a virtual file system, primarily stores information about devices. Oh, yeah, right. That are stored in various subdirectories under device location, which represent okay. So that is device information. I was never quite sure about the difference between sys and dev, but I think dev is the actual dev contains the APIs, so to speak, to the devices that you can send commands to, and sys contains the information about the device, and that is sort of how they differ. Because like if you have standard output, or if you have error messages, you can send those to dev null and then it'll disappear. If you like stuff in dev is some sort of API that you can talk to in some way, or that other applications can talk to. Sys should just be information. I'm not sure if I can take a look at that actually. ls minus la sys. Okay, cat this dev. Is there anything in there? Block. All right, sure. Can I look at anything or raise? Disabled. Okay. So that is an actual text file. I'm not sure what all of the others are, but I would assume they are also text files. So you can find generally text files in the sys subdirectory, which is a useful thing to have, I guess. Usually text files. SVR, web server. Yeah, that's it. It's just like web servers, static files for web servers. That's what it is. Temporary files that may be lost. Yeah, okay, fair enough. Small programs and files accessible to all users. System resources. Small applications for all users. Except USR SBIN, which is only for super users. User local. Oh, there's a lot of subdirectories here. Bin local lib object libraries and internal binaries that are needed by the executable programs. Oh, okay. So USR, I was always wondering what that was. Libraries required by the binaries stored in USR. If it's anywhere else, that's not where that is. It's also application specific because everything else, any shared library would be in root lib. So it's the same purpose as you accepted them for 64-bit systems, okay? USR share, read-only independent files can be shared among different architectures of an operating system. That's, I don't understand what that means, but I don't think that's a problem necessarily. Var, variable files or files that are expected to constantly change. Yeah. Log files, printer spools, networking. Okay. Maybe I want to write that down. Web server file. Web server, static files, printer, spools, network, whatever. What's it say? Network files? I'm not sure. Some manner of network file. Admin var. Okay. The directories, home, root. Okay, gotcha. And I think that's all that my brain is willing to deal with. I just need to make sure I remember that these directories exist because I'm forgetting half of them. Okay, let me just see. Not which ones do exist, which were the ones that I forgot initially. When I listed them the first time, I forgot about root, I forgot about opt, I forgot about run, about sys. I did have USR. I did think of USR, but I didn't write it down. Media, I did have. Mount, I did have. Dev. And I think that's all the ones that I forgot about initially. That's pretty good, but could have been better. Could have been better. Could have been better. Boot. God, never forget about boot. If you forget about boot, well, you're not booting your system, and you die. Well, you don't die, but you know, it hurts. Pain in the butt. File naming conventions. Oh, there's naming conventions. What naming conventions, pray tell, are you talking about? A file name is a string of characters. Fair enough. Oh, wow, really? I wouldn't have guessed. By using the right combination in file names, you can ensure that the files are unique and easy to recognize. On an ext4 file system, which is a type of file system, I think the most common are ext4 and btrfs. Maybe 250 bytes long, that's okay. And contain any byte except null and /, obviously, because that's the path denominator or whatever. File names of user files may not be a single dot or two dots, which is also obvious. Yeah, fair enough. Can't be. Alright, file names can't contain a null, they can't contain a /, they can't contain a dot, they can't contain a double dot. Gotcha. Although file names may contain a space, convention is that they don't. So you either use a hyphen or an underscore, and then everybody is happy and nobody hates you. Wait, what do these do, by the way? That displays the file metadata. Okay, and file different metadata. Well, why do we need when do we need two commands for metadata? What is this? Stat sample. What am I looking at? Size 0, block 0. Okay, that's the size of a file. Gotcha. Device inode. Oh, it shows you what inode it is. Last access, last modify, last change, and creation date. Okay. What does file give you then? Sample, empty. Okay. How about content? How about I just put that in there? What do you say then? ASCII text, okay. It tells you what sort of encoding it is. Okay. That might be somewhat relevant. File encoding. Oh, it's like file type and encoding. And this is storage information and creation modification information. No, creation modification and access, actually. Gotcha. Yo, how late is it? Like 12:14. I want to take a break. I don't know. Let me take a look at the next chapter and then decide. Absolute and relative paths. Oh, you don't say. You don't say absolute and relative paths. I don't know what that is. Come on, man. Give me some credit here. Defines the series of directories to be traversed. Oh, well, I actually got a definition of a path. If you had asked me what a path is, I wouldn't have been able to give you an answer, to be honest. A series of directories to be traversed to find a specific thing. To find a file or subdirectory, okay. Is stored in the resources of your home directory. The path defines what directories to travel through to arrive at the file. Okay. So it is a path is basically a descriptor for an application to know what parts of the storage to traverse to find a thing that it needs. Okay. Defines the directories to traverse starting from the root. Absolute path always starts from the root. Okay? I'll read it anyway. Never trust the brain. The brain tells you you know things, you don't know them. You don't know the things that your brain tells you. Never trust the brain. Recall that the file system root is depicted using a /, as is customary on Linux. The absolute path is the complete path from the top of the directory structure. Suppose a user named student user wants to find the widgets.txt, which is stored in the inventory subdirectory of the resources directory of their home folder. So it's, without looking at that, it's home, resources, what's the last one called? Home, resources, inventory, and widgets. Yeah, okay. It also needs their name in the home directory, obviously. Relative path is dependent upon the user's current location, which you can find out with pwd if you're on a Linux system. Or you just read it. You just look at your command line and you goddamn read it. That's another option that you have. Using the above scenario, if the user is already in their home directory, then the entire path is unneeded. And all that needs to be specified is the remainder of the path from the current location. Assuming that the user is in the home directory, yeah. Okay, just to complete this, you can write stuff as, I don't know. If you want to execute a script, you can write it as this if you're in the same directory. You can also write it like this, because dot is always the current directory. And this is always the parent directory. So if you were in your, I don't know. If you were in your home honey sample and you wanted to go to root, you would do like this, I think, and then you're at root. Right? I'm not using too many dots, are I? Am I? Are I amming? Yeah, that'll get you back to root. Crazy combinations of relative paths. Okay, filings. Oh god, I don't want to deal with those. I know what links are, but I'm always tripping up on the difference between hard links and soft links. I think hard links are, god. Hard links are retained even when you delete the original file. And oh god, I don't know. They basically occupy their own inode, like their own file. Anyway, that's a little too much for me to deal with right now. Okay. Actually, I think it's time for a break then. We've been here for 1.5 hours. That's good enough for a Sunday. Oh, good. Okay, that's it. That's good enough. So, as an overview, we've done some permission things with default permissions, special permissions, and access control list. Understanding that access control list, get FACL, and set FACL are not actually by default installed in Debian systems, which is very interesting. The sticky bit allows or makes it such that a file can only be deleted by its owner. The setgid for files makes it such that a file is executed as the original group, and the setUID makes it such that the file is executed as the original owner, and the setgid on the directory makes it such that, fair enough, on the directory makes it such that all files created in the within the directory are going to be assigned to the directory group, and all subdirectories will also be assigned to the directory group, but also have their GID bit set. Okay, gotcha. Good. We're taking a break for now. and maybe play more Expedition 33 later, because now my brain is sufficiently bothered. Everyone is still here. Have a good day. Take care of yourself. We'll be back later, and you can join then if you want to. If not, then I don't know. I guess I'll see you whenever. Take care and goodbye.